Welcome to this month's first FDTD Satellite Applications webinar. Today we're very happy to have Dora Meredith, who is a meteorologist from the forecast office in Pago Pago, American Samoa. Dora is from American Samoa, went to college in Hawaii, and is now working back in Samoa. And her talk today is forecasting heavy rainfall in American Samoa with no radar, because there is no radar on the island. Okay. This is part of a series of presentations presented by National Weather Service forecasters, so it's peer-to-peer learning. They are all archived at this website that is in that blue box, that fairly gray link. Dan Bikos and I'm Scott Lindstrom, we're always looking for speakers. So if you know someone who has advocated for satellite use in your office or has a good case study on why satellite use is really helped with a particular forecast, let us know. We'll get in touch with them. We'll help create it. We'll help create imagery if needed, and then you can give a talk also. Just some protocol, about 20 minutes for the speaker. You can send questions via the GoToChat or ask during the Q&A via the phone. We should be done around 18:30 UTC. Don't press hold, mute when you're not speaking. Take it away, Dora. Thanks.
Hello, everyone, or talofa in Samoan. So thank you, Scott, for the introduction. Can you see my screen?
Yes, I can.
Okay, I'm assuming, yeah. Okay, so thank you guys so much for the opportunity. So to get a better understanding on how we forecast for American Samoa, I will share with you a bit of climatology for our island first, and then this way you will know why we use the tools we use for heavy rainfall expected, and especially the important role that the satellite data plays in our area. So we are located in the tropics, and my office is the only National Weather Service office in the Southern Hemisphere. So we are around 14.3 degrees south of the equator and about a 5-hour plane ride from Honolulu. So quite some distance to where you are. For our climatology, we have a wet and dry season, although for me, it seems like we have a wet season and a wet but not so wet season. So even though we have a dry season, we still get plenty of rain year round. So our annual average is, as you can see on the chart, 128.34 inches for our wet season. Our highest average is in January, and then for our dry season, our lowest is in June. So just last year, we broke the annual rainfall record of 165.41 inches set in 1981 with a total of 191.68 inches. So this was in my abstract. I did have a mistake on my abstract, but this is the latest number for the record we broke last year. So overall, hydrology is the most important aspect of our weather. We also have barotropic weather patterns. So usually we'll see shortwave troughs, shear lines, and showers embedded within trades in our area. And then the South Pacific convergence zone is also oscillates back and forth in the area. So you see the line over us in this image, and depending on the ENSO pattern, and this is where the position of the SPCZ, or the South Pacific Convergence Zone, will be. So for American Samoa, when it is in a neutral to El Nino pattern, this line is usually sitting right over us, and along the SPCZ, tropical systems tend to form or develop right over us. So here's an example of a recent storm that we had in the area, which is Tropical Cyclone Gita. It impacted us in 2018, and as you can see the SPCZ line, and just embedded within it was the storm. So these are the typical storms that we have and how they develop in the area. So here are some of the challenges that we faced for forecasting heavy rainfall. And as Scott mentioned earlier, we do not have a radar. So we have global model data for predicting precipitation, and it is very coarse resolution. We also lack high resolution mesoscale models. So we do have the WRF from the University of Hawaii, but no high res window and NBM. Model QPF is also limited, so it tends to underestimate and overestimate rainfall amounts. Doesn't take into account terrain and diurnal heating, which diurnal heating occurs on a daily basis. And then for terrain, we have rocky mountains all over, for each island of American Samoa. So overall, we lack resources and only have the weather balloon for surface observations, as well as the observations manually inputted by our HMTs. Then we have our satellite data, which is a very important tool for us, and we learned how to utilize it to our best advantage, especially over the years. So more forecasting challenges. Obviously, again, we do not have a radar, no upstream observations. Where we have the balloon, it's only on one island of Tutuila. We don't have any balloon data from around us. So a lot of the islands around us, they rely on our balloon data. So it doesn't give us a good idea of how an air mass is over the territory. And the ASCAT, we do have the ASCAT. It is very useful, but it tends to miss us, but it still gives us enough information to kind of see what's going on around us. And then we do have AWIPS, but it's the thin client, so we don't have all the features that the AWIPS has to offer. So how we work around it. Like I said before, satellite data is key to our forecast. So following the trend on features from viewing from above definitely gives us a better view of what will happen next, and just following that trend. Also, our one sounding is very crucial. The unfortunate thing about that, like I said, is the no data upstream. So we use our observations, and then we check if all these ingredients are expected or in the models or in our observations for heavy precipitation. And these ingredients are abundant atmospheric moisture, lifting mechanism, and instability, which you will see in some of the analysis that we did for an event on July 4th weekend of this year. So this is what happened on July 4th weekend. We had widespread heavy rain showers, flash flooding in different areas, starting on the night of July 4th, especially within the harbor area, which is a central part on the main island of American Samoa, which is Tutuila. So on the video recorded by one of our HMTs who lives in that central area, you can see water rushing downstream on a residential road. This led to flooding in front of a Catholic church about a mile away. Let me pause that. I don't know if you can hear me. Okay. So this event also set off alarms on our One Rain program, showing more than an inch of rain in an hour for that central area. So that's the map that you see of our One Rain program. And then the photo with the rain gauge overflowing was reported on the western part of the island. So the day after, which was July 5th, 3.4 inches of rain was recorded over an 8-hour span in the harbor area. After this long weekend of events, landslides were reported in several parts of the island. So you can see, so the 3.4 inches that I mentioned is on the chart, which is a good flash flooding indicator. You see that peak. And then on the bottom photo with the landslide, this was seen the day after. It was taken in front of my parents' house. So go figure. It happened where my parents were someone I knew. So thankfully, we were able to issue a flash flood watch ahead of time to warn the public of the hazards we were anticipating. So how were we able to issue a watch when model data wasn't forecasting flash flooding conditions? Let us continue. So if I didn't mention before, when all of this happened, model data wasn't saying that this was going to happen, and I can show you in our next slide. So here is an initial model data before the event happened, which was the July 3rd afternoon model run. So although the runs prior to this one kept a consistent pattern, we decided to take record of this run as we had a higher confidence in our forecast by this time. So this GFS QPF surface model show a QPF of maximum of 0.25 inches for the July 4th weekend, with higher QPF values on the night of July 4th and through the following night of July 5th. So just 0.25 inches, it doesn't really show much. Looking at our next model run to get a better understanding of the profile of the atmosphere projected over time, we developed this cross-section for relative humidity from the surface to 200 millibars on AWIPS for both GFS and the EC models. So for this GFS model run, you can see high relative humidity values greater than 80% for the July 4th weekend. However, this is an underestimation from the typical flash flooding profile indicator that we usually see that has a deep and moist profile from the surface up. So for this case, you can see high relative humidity values stopping at about 500 millibars. For the EC run, it shows an even shallower and moist profile going up to 700 millibars for that time frame. However, the EC always tends to underestimate rain for our area. So with the model data I've just showed you, I return to the question, why did these guys issue a flash flood watch when flooding conditions weren't there? As I mentioned before about the ingredients for heavy precipitation, 1, abundant atmosphere moisture, 2, a lifting mechanism, and 3, instability. You will notice the first two in this next model data that I'm about to show you. So the theta E model data depicts areas in the atmosphere where both heat and moisture are pulling or converging. So as these parameters are needed for convection and increased risk of rainfall, the axis of high equivalent potential temperatures, or theta E, is a good indicator of areas that have a higher likelihood of producing flooding rains as compared to areas that are more short-lived rainfall events. So for this weekend, for the July 4th weekend, you can see high potential temperatures lingering over the islands. So the islands are in the circle. And you can see those yellowish, greenish colors for the July 4th weekend. So those are showing high potential temperatures. And then there's also, if you're looking at the streamlines, you can see converging winds. So good indicator for lift and flooding is shown on this GFS model run. So the Galvez-Davison index is also very good for our area, especially for forecasting convection in our tropical region. As you can see here, the model is very coarse, only 0.5 degrees, but just following the trend, we see high GDI values during that July 4th weekend. So our observations that we took on this day, the day before July 4th, just to kind of compare the model data and the observations. The Pacific Streamline analysis for the South Pacific is usually prepared by the WFO Honolulu, and this analysis is very helpful for our office in confirming significant weather features that we are always looking out for. So as you can see, the stationary front is just, or cold front, stationary front, cold front, just to the south of the territory in the purple circle. Looking at satellite data, or the total precipitable water, you can see a stream of high precipitable water values associated with the front. So the TPW is on the left-hand side, and you can see the TPW values increasing and in line with where the front is. And on to the right-hand side, the microphysics channel, we usually use this because IR observation doesn't capture low-level features well, but you can clearly see the front from this channel. So microphysics is good at highlighting different cloud layers, and I was looking at this at night, so it was a very helpful tool. The upper soundings for July 3rd showed a slightly stable and dry profile in the afternoon. Then for the midnight run, it became a little moist and unstable, with K-index and total values increasing, as well as the TPW values. However, still not a flash flooding profile, but just looking at the trend, we were seeing that instability and moisture increasing over time. So because of all the uncertainties that I mentioned, we pushed out our messages on social media. So we're like, hey guys, we're expecting heavy rainfall. This may or may not happen, but this is what we're seeing. And just to keep the public, to have the public watching what's going on, or just to prepare the public for impending or the heavy rainfall we were looking at. Also, July 4th is a holiday, so it was very important for us to get this message out. So looking at model data 24 hours later, the afternoon run for the day of July 4th was bringing in even lower QPF values. So it wasn't as red, it's not as red as as enhanced as the model run from July 3rd. For the GFS RH cross section, it was showing an even shallower profile than the one on July 3rd. You do have some moisture building up at the top, at the mid to upper levels, but still not flash flooding indicator that we're used to seeing with the purple and pink colors extending all the way up. The EC, on the other hand, was a bit more moist for the desired time frame, but still not a flash flooding profile. However, what remained consistent was the theta E. As you can see here, still showing high potential temperatures as the front was anticipated to linger over the territory. So still heat and moisture converging over the islands the night of July 4th through the night of July 5th. GDI, or the Galvez-Davidson index, was also keeping those convective or high GDI values when the front was forecast to move over the islands. So looking at the observation, the Pacific Streamline analysis was saying, okay, now the stationary front is over you. This is on the July 4th day. And from our satellite data, the TPW was showing increased TPW values, or total precipitable water values, of more than 2 inches of rain over the islands. And I was a forecaster on shift, and I started to see convection forming over the Samoa island. So we are in the circle, and then I don't know if you can see my mouse, but there was convection building towards the west of Tutuila. So here is Tutuila. And then, we again, using microphysics, we saw the convection, the different cloud layers, and it was becoming more convective. So looked at the balloon data and saw that the K-index values were high and the PWAP was above 2 inches. So, these are some of the parameters that we look at for instability and moisture for the balloon. And we had moisture from this sounding, the noon sounding moisture. We had the lifting mechanism, and from the sounding we saw instability. So all these ingredients pointed to a likely heavy rainfall event. So I was a forecaster on shift, and I issued the flash flood watch around 4:30 p.m. Samoan Standard Time, and Lord and behold, A few hours later, around 7 p.m. on July 4th, we were pounded with heavy rain. So the midnight balloon, which is the one on the right, and this was after we were pounded with the flooding, the heavy rainfall, you can see that flash flooding profile, moist from the surface to 100 millibars, which we didn't see in that RH cross section in the model data I was showing you earlier. So thankfully, we did a very good job at pushing out our products and updates for this event. You can see here we had a flash flood watch prior. Then during, we had 3 flash flood warnings and 1 small stream flood advisory. Unfortunately, if only all our forecasts were like this, but however, because we don't always get 100% accuracy for our forecasts, especially without a radar, we have had incidents where our forecasts were not on point, and I'm taking us to the next section, which Scott and the team was very helpful in helping us analyze this event. So here's an unsuccessful event example. So here is an IR imagery. This was taken on July 31st, 2020. And from this infrared imagery from Scott, thank you, Scott, you see not much happening over the islands. Also looking at visible, you still don't see much happening over the islands. There you can see some unstable low-level clouds, but still doesn't look like much. However, this was what was happening on the island. So because of this event, all the forecasters kind of went back to revisit and to analyze what was happening during this day. Unfortunately, we weren't able to get model data prior to this time, but our forecast was showing scattered showers, which is 30 to 50% chance of rain for this day. But as you can see, that was not what happened. We had flash flooding all across the central area. This is town area for the island of Tutuila. And yeah, you see cars having difficult time traveling. Then there were rock slides. The walls weren't strong enough to hold the water, and it just came out. So a few miles away from this event is where our weather office was located, west of the island. And because our weather office is on the driest spot of the island, we didn't see this much rain. So all of this were reported by the public. And here are some of the observations that we that we recorded for this day. So at the Si'ufanga Ridge, one of our sites recorded an inch of rain from 12 to 2 p.m. Samoan Standard Time, and recorded about an inch of rain. And just a few miles east of that, Tall Ridge recorded 30 inches of rain within the same time span. So see that drastic change just a few miles away from the other gauge. We were able to get the TPW, or the total precipitable water, data from Scott to kind of assess what was going on this day. And prior to this event, we didn't pay much attention to TPW because we were still learning the different satellite features. But after this event, we all started focusing on TPW, because over here you can see moisture pulling over the territory, which is in the circle during that time frame, the July 31st time frame. For our ASCAT run, it did show that there was some sort of a wind convergence, not too drastic, but just enough to get some sort of lift. However, we do believe that terrain also might have been a factor, because in the harbor area, it tends to be the most wettest spot on the island of Tutuila. And then looking at our sounding for that day, just moist at the surface, but not a flash flooding profile like the one that we saw on July 4th. So it was, this was the midnight run, the night before July 31st, which didn't show much, and which didn't show the forecaster on shift that, you know, anything like what we saw was going to happen. But the balloon did show high K index values, and that instability was there. And then the noon run, which the sounding on the right hand side was sent up during the time of the event. So you can see it's a little bit more unstable than the previous sounding. So all in all, as you can see, we lack a lot of things, but we do use what we have to the best of our ability. And thankfully, we just got high-speed internet not too long ago, which gave us better access to AWEBs. And because of all the uncertainties, like I mentioned before, social media is key in pushing out all our messages. And then we do have the ASPA rain gauges that are helping with a lot of our case studies, but the unfortunate thing about the ASPA gauges is that it's manually recorded, so there's some missing data. So yeah, but that's how we work around it. Thank you for having me today. If you have any questions, please feel free to ask.
Thanks, Dora. There are a couple questions. I just have a comment first on the
Yes.
use of the nighttime microphysics RGB,
Yes.
which I'm really happy to see that. I think that's a great use of it to see how the lower clouds change color as convection starts. But we do have a question on that. Yeah, here we go. What features do you look, this is from Vanessa Vincente, what features do you look for in the microphysics RGB that would suggest a heavy precipitation event was possible?
Okay, yeah, so for us, it's just those, like, I don't know, I call it popcorn clouds when you see, it's just looking at the feature developing over time and having that like rise. I think when you look at the satellite a long time, you get to develop like that eye for it. But to me, it looks like an explosion, I guess, on the satellite. So for the microphysics, seeing more of that red dark color kind of popping out on the screen, that's how for me personally, I see that most likely heavy rainfall is within that area.
And I'd say plus knowing that it's moist and there's
Yes, of course.
There's moisture to be
all of the
condensed.
ingredients that I mentioned. Yes, but usually just from looking at it over time and keeping training your eye to look at it all the time, you just can see like it has like a look. I don't know if that helps, but yes, knowing all those ingredients are there is helpful.
And there's another question from what's the GFS resolution of the data that you get on AWIPS? Do you know offhand?
GFS, I don't know. Off the top of my mind, I know I do know I have it in my notes somewhere, but yeah, I can follow up with that question, but I do know it's not very high. Like it doesn't see terrain well.
Right.
Yeah, for us, for Hawaii, it's really good, but for my island, because it's smaller, like you can't even see any effects of terrain on whatever passes through.
So do you have like a feel for how many actual data points you have on Tutuila?
Data points like for
from the GFS model there. I mean.
I think it's just the balloon, the sounding.
No, I was talking about the GFS data. So if you're looking at individual data points from the GFS model that you get, I'm wondering if you have any feel for how many points are actually on. I always have trouble saying it, Tutuila.
Oh, I'm not so sure. I'm so sorry.
That's okay.
Yeah, I can get the answer to those questions, but I'm not too sure. Oh, we don't have one. Oh,
There's
okay, sorry. My boss is also listening on the chat, and she says we are just low res. We don't have data points, so it's
okay.
just from yeah.
Other than the microphysics RGB and the TPW, and I know you showed the ASCAT, do you use
Yeah.
any other satellite imagery or products to help you know if heavy precipitation events are possible?
Oh, we do use the Viz, but what I was showing was because I was working the swing shift, so that's why I was using the microphysics one, but Viz is actually the best for satellite, but at night we use microphysics. So other yeah, then soundings, that's about it. Everything I mentioned is really what we look at.
Okay.
Hmm.
I see a lot of other comments in here, but I'm mindful of the time. It's a
Okay.
little after 18:30. I'll just read one comment from Jose. Um, Glad that the GDI is useful. There are some resources of the GDI coded in other models, like the Galvez index. I wonder if there's any
Ooh,
relation. I wonder if there's any relationship between those names. There are some commercial websites and some inside the Weather Service that have resources for getting GDI inside AWIPS. So um,
wow. Okay, I wonder if it'll work for thin client. That would be awesome because we
and
have to go on their website.
right, the and I will just mention before we close that I know that IMETs have been using at Fires have been using thin client, but they're now using AWIPS in the cloud. And I'm wondering in the future in your office how much use AWIPS in the cloud might be there. But that's a question for Eleanor and
Yeah,
Eric, the Pacific
yeah.
region. But
Okay,
I
yeah,
want
that's the
to, yeah.
plan. That's the plan. Ellie just gave me the thumbs up. That's the plan.
Okay.
So I hopefully I know because now we're used to A-Waves and then we're like, okay, when can we upgrade? Because we're ready to move on to the next level.
Yeah. Well, I want to
Yeah.
thank you for the presentation today. Um,
Yeah.
it's always great to hear from the Southern Hemisphere for the National Weather Service. We will have another FDTD webinar in 2 weeks on the recent Tennessee floods. So look in your inboxes for emails about that. And thank you for the presentation today, Dora.
Thank you, and please send your emails. I don't mind. I'll find all the questions you have. I'll try to answer all of them. Thank you.